this one, the graph looking like a mouth of a pelican right there. You see a pelican's mouth right there? But when you find the area is just top curve minus the bottom curve. So you could even list that just f of x minus g of x. You don't have to write down the whole function, although I did on this one. But just math 9 that thing, get that answer right there. Simple. All right, letter B says find the volume of the solid shaded region. We're going about the line y equals 2. So y equals 2 is about this horizontal line right here. All right, and we're going to do the disk method here. We're going to draw a rectangle perpendicular to that axis of revolution. Everything is in terms of x's there. We're going from a curve to a different curve there. That's good. Now your capital R is a distance from this axis of revolution back to your farther edge. And then your little r is a distance from this axis of revolution to your closer edge. That's one of our 4 big scenarios. Anytime you measure from that axis down, it's that number minus y. So I need you to do those 4 big scenarios. So notice on both of these, I did 2 minus y, 2 minus y. And then that capital R was to the farther edge. So this y was our g of x equation right there. And then the little r was to your closer edge. So that y was your closer equation, was your f of x right there. So there's my capital R, 2 minus that g of x, and then there's my little r is the 2 minus the f of x. I got my capital R squared, little r squared. If you wanted to graph both of these into your calculator first, you don't really need to do that on this one because you don't need the intersection points. You know you're going from 0 to 1 for all of these. But if you wanted to just have your alpha trace shortcuts in there and then type those in once, and that's an option, okay? But I didn't have those in my calculator, so I just kind of just typed those in at that point in time. But what I want to mention there, sometimes people get confused because the graph goes below the x-axis there. It's still your 4 big scenarios. I want to taught you those 4 big scenarios and told you those always work if they didn't always work right there. It's not additional. So when you go 2 minus y, this whole distance is 2. And see, this y right here is going to be a negative value. So like, let's say this y value is a -3. This distance would be 2 minus that -3. When you go 2 minus that -3, it turns it into 2 plus a +3, and it works. Okay, so if you're confused on that, you could let me know, and we can ask some questions about that. But you know, just stick with your 4 big scenarios, and you're going to be safe with that stuff there. Math 9 it. Please make sure you're practicing this in the calculator so you get your speed up with these things and round to 3 numbers after that decimal right there. Letter C looked worse than it actually was. I saw that big paragraph. I saw K's and stuff in there. Sometimes that gets really tricky, but this is actually a pretty decent problem, okay? So it gives me this new function, and then notice that the new function and this f of x function are the same thing, except for that's a 2 and this is a different number. Now that might be a 1/2, and that just means the pelican's mouth is going to be slightly shorter, or that could be a 4, and then the pelican's mouth is going to be slightly higher right there. But I know the basic shape of this thing is still going to be, that's the top curve, and I still got my g of x on the bottom right there. So it's still pretty much the same basic shape, although I don't know what the k value is. And then it's talking about the base of a solid square cross section is perpendicular to the x-axis. So I start thinking about that cross-section method. Cross-section method is we draw on the S perpendicular to that given axis. They tell us the x-axis there. I find the length of that, which is the top y minus the bottom y, and that's just that top curve minus the bottom curve. There's my S right there. And then remember, that's one side of your shape. So since they say we're using square cross sections, that's our easy one, right? We like the squares. You just integrate the area of your cross-section shape. So you integrate that thing squared. So I integrate that thing squared between 0 and 1, and they tell us that volume is equal to 15, right? So it says write, but do not solve an equation involving an integral expression that could be used to find the value of k. So you need to have the equal sign right there because it says write an equation. And then they tell us that volume is equal to 15. So it's just like your cross section. They tried to trick us up a little bit with that k in there, but you'll see some more stuff with k's in there in the future. Now, technically, if they wanted us to solve it, they would have to give us something a lot easier to work with there. So like, for example, if they were to give us a simple, hey, I got the integral of kx squared from 0 to 1. And then I set that equal to 15. I can easily solve that one, but they wouldn't give us something that crazy to solve it if they had. That's why I said do not solve this one. But realize you could go kx cubed over 3 and then plug in the 0 and the 1. Then you can plug in the 1 for the x. So that'll give us like 1/3 k minus 0 equals 15. And then we can get that k value is equal to 45 right there. So just kind of keep that in mind in the future. If they do ever have us solve something, you could just straight integrate that thing, treat the k as a constant, and then plug in some numbers, and then you'll have an equation with the k's involved in it. Mailbox.